Here this question is asking overall an interval t is equal to t is less than or equal to 1. An angle modulated signal is given by phi em of t is equal to 10 cos 13,000 phi t. It is known that carrier frequency omega c is equal to 10,000 phi. A part is asking, assuming a PM signal with kp is equal to 1000, determine m of t over the interval t is less than or equal to 1. And the B part is asking, assuming an FM signal with kf is equal to 1000, determine m of t over the interval t is less than or equal to 1. Okay, let's see how to do that. Now here this equation is given, we can rewrite it, given that phi em of t is equal to 10 cos 13,000 phi t, and also the frequency omega c is provided. Omega c is provided, that is angular frequency, that is 10,000 phi. And from this one we can solve for the fc, that is carrier frequency. Here omega c can be written as 2 phi fc, which is equal to 10,000 phi. Therefore fc is going to be the whole thing divided by 2 phi, so that's going to give us 5,000 hertz. Okay, now we have the carrier frequency, and we have this one. Okay, and we can express this phi em as this one as well. Phi em is equal to AC cos 2 phi fc plus phi naught. Okay, and we know that 2 phi fc is 10,000 phi, and I'm looking at this here. AC is 10 in this case, and 2 phi fc is 10,000, so this phi naught must be 3,000. Okay, so we can just write the theta of t, this cos theta. So theta of t we can write as 2 phi fc plus phi naught, and 2 phi fc is 10,000 phi, 10,000 phi, and this one is cos omega t, so 2 phi fc t, and this phi naught is the rest of them. So this is 10,000 phi t, and then okay, so this is 2 phi fc t, and then this is 10,000 phi t, 3,000 phi t remaining, that is a phi naught. So that's how we got theta of t 13,000 phi t. Okay, let's note these two things down. Now we can go ahead and deal with the A part. In the A part, assuming PM signal kp is 1000, determine m of t over the interval of t is less than or equal to 1. Let's go ahead and do it in the next page. So I'm doing the A part here, and theta of t can be represented as omega ct plus kp m of t. And here we are interested in finding m of t. That's what the question is asking, and we have to find the interval of that. So in order to solve this one, we can rearrange this in terms of m of t. So this is going to be kp m of t is going to be omega ct minus theta of t, and therefore m of t is going to be omega ct minus theta of t the whole thing divided by the kp. Now we have all these values available. Omega ct is the 10,000 phi t, and then theta of t is 13,000 phi t. Okay, you know what, I made a mistake here. If I move this omega ct to the other side, because I want the kpm to be positive, so it's going to be same side here. So this omega theta of t minus omega ct. And here also same thing. Okay, now we know that theta of t is 13,000 phi t, and we know that omega ct is 10,000 phi t, and that one divided by kp that's provided in the question, that's 1000. So we are going to get 13,000 minus 10,000, that's 3,000 divided by 1000. So we are going to get 3 phi t. Okay, so m of t is 3 phi t. So here we are interested in the interval, that is when t is less than, or absolute value of t is less than or equal to 1, and m of t is going to be 3 when t is less than or equal to 1, and 0 in other areas. Okay, so that's the answer. So that's what we have to find. Okay, determine m of t over the interval t is less than or equal to 1, and this is it. Okay, now A part is done. Now let's look at the B part. And in the B part we are dealing with the FM signal and KF is provided. We have to find out the m of t. Now for this one, if we solve for the f of t, that is equal to 1 over 2 phi over the derivative of the theta of t, that is 10,000 phi t plus 3,000 phi t. Okay, and so if you take the derivative of this one, all the t terms will be gone, so you will get just 13,000 phi. So 13,000 phi will be divided by 2 phi, and that's gonna be 6,500. 6,500. 500 hertz, and that's our f of t. And there's an equation that f of t is equivalent to fc plus kf m of t. So here if you solve for the m of t, that's what we are interested in. So that one become, if you rearrange this equation, f of t minus fc, and if I bring the once it's gone, then it's going to multiply by this. If I go to the other side, that's going to divide, so divide by kf, that's equal to m of t. Okay, and here we are going to solve for the m of t. Therefore m of t is going to be f of t, that is 16,500, and carrier frequency we already know that from the beginning, that is 5,000 divided by kf is 1000 given in the question, and if you solve for zone, this is going to be 1,500 divided by 1000, that is 1.5. Okay, m of t is 1.5. and therefore the interval for the m of t is going to be 1.5 when t is greater than or equal to 1 and 0 in the other areas. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.